Geometric Growth and Decay, Explicit Form, Worksheet. So, here is the worksheet for the rules of the nth term or explicit form in a sequence modelling geometric growth and decay. First, we're going to look at compound interest loans and investments. So let's have a look at the first question there. So a principal value of $20,000 is invested in an account earning compound interest at a rate of 5% per annum. The rule for the value of the investment after n years, Vn, is Vn equals 1.05 to the power of n multiplied by 20,000, where Vn is the value of the investment after n years. A. Find the value of the investment after 5 years, correct to the nearest cent. So here we just substitute 5 where n would be, and we end up getting V5 equals $25,525.63. So B. Find the amount of interest earned after 5 years, correct to the nearest cent. So now we've got the interest equals the amount after 5 years, subtract the initial value. So we have the interest equals $25,525.63, subtract $20,000, and that equals $5,525.63. C. Find the amount of interest earned in the 5th year, correct to the nearest cent. The difference between what we did in B to C is now we've got the interest equals the amount after the 5th year, subtract after the 4th year. So now we have the interest equals $25,525.63, subtract, and here you can just put in the rule for the 4th year and just substitute 4 for n. So we subtract 1.05 to the power of 4 multiplied by 20,000 equals $1,215.50. Okay, D. If the interest compounds monthly instead of yearly, write down a rule for the value of the investment after n months. Now this whole line here shows just how the common ratio can change depending on how many times the investment is compounded. So the common ratio equals 1 add the interest rate divided by the number of compounds, then divided by 100. Now what we do is we substitute 5 for the interest rate and 12 being how many months are there in a year. So how many compounds are there in a year? In this case, because it's monthly, it'll be 12. So now we just go 1 add 5 twelfths divided by 100 equals 1.0042. E. After we use that rule, we've got Vn equals 1.0042 to the power of n multiplied by 20,000. So now we're up to E. We can use the rule now and substitute 60 because there are 12 months in a year, and 5 multiplied by 12 equals 60. So the question was asking us, find when the value of the investment after 5 years or really use this rule to find the amount of the investment after 5 years. I think that's what it's actually meant to say there. So we just substitute 60 there and we should get $25,718.35. Okay, our last question on that page is using the CAS to solve geometric growth problems. So we've got how many years will it take an investment of $3,500 paying compound interest at a rate of 7% per annum to grow above $5,000. Well, first of all, we have to work out what we're trying to solve. In this case, we know our place value, which is $5,000, or our present value. It equals 1.07 to the power of n. Now that 0.7 is 7% converted into a decimal, then add 1 due to the compound interest. So 1.07 to the power of n multiplied by 3,500. Now we can use the class pad to solve. So here's the class pad. I'll bring it up here. We can use the solve function, type in 5000 equals 1.07 to the power of, it doesn't have to be n, we can make it x this time, and multiply by 3500 and comma the variable we want to solve and execute. And we get 5.27. So let's just have a look if that's what we were meant to have. Yep. So the n equals 5.27, but that is after the 5th year, so it's really into the 6th year, so therefore we say it would take 6 years. Okay, reducing balance depreciation. So in this question, we have a home entertainment system costs $9,000 to buy and decreases in value with reducing balance depreciation by 15% each year. A recurrence relation that can be used to model the value of the home entertainment system after n years, Vn is shown below. So we have the initial value being $9,000 and then Vn add 1 equals 0.85 multiplied by Vn. And now what we have to do is A, write down the rule for the value of the home entertainment system after n years. So now we can just substitute our known values of 15 and 9,000 into the rule. You can see at the top of the page there. And therefore we get Vn equals 0.85n multiplied by 9,000. Now you'll notice there's a relationship between the explicit form or the rule for the nth term and the recurrence relation. So just note where the initial value goes and where the common ratio goes. Alright, B. Use the rule to determine the value of the home entertainment system after 6 years. So what we do is we just substitute n equals 6 into the rule and we end up getting $3,394.35. Okay, C. Calculate the total depreciation of the home entertainment system after 6 years. So to work that out, we have to start from our initial value of $9,000 and compare it to the amount that home entertainment system is now after 6 years. So total depreciation equals the price, subtract how much that home entertainment system was after 6 years. We substitute 9,000 into our equation there, so we get 9,000, subtract our solution from B, which was $3,394.35, and we end up getting $5,605.65. Okay, our last question. So using CAS to solve geometric decay problems. So Mara Silent College purchased a computer system at a cost of $65,000. It has an estimated value of $12,000 after 9 years of operation. If the value of the computer system is depreciated using a reducing balance method, what is the annual rate of depreciation correct to 1 decimal place? So again, what we have to do is substitute our known values. So we know our present value is $12,000. That equals, in brackets, 1 subtract R divided by 100 to the power of 9 multiplied by an initial value of $65,000. We can now use the class pad to solve to find the value of R. So like we did before, and I'll just bring it over here, we use the solve function. We go 12,000 equals, in brackets, 1 subtract, instead of R we can use X, okay, to the power of 9, and we multiply by 65,000, and don't forget the variable, so comma variable, and execute. And we get 17.115, so let's round that to 1 decimal place. We should get 17.1% per annum. Let's have a look at what we are meant to get. And there we go. So our interest rate there is 17.1% per annum.